Welcome back to Continuous Profiling with Coralogix. In our previous videos, we introduced continuous profiling, explored the interface, and learned how to analyze performance data. Now we're going to focus on applying these insights into production environments to help optimize our applications and reduce infrastructure costs. So let's walk through a complete workflow with continuous profiling. This would typically begin when alerts start triggering. We're starting to see some symptoms of application degradation. And we can also see this within our APM service catalog. Compared to a day ago, we can see that we have over a 200% increase of errors in our product service catalog. It's quite significant, so let's go in and take a look. We now have a detailed dashboard here showing us performance metrics for our product catalog service. We can see things like our average latency, we're taking over 11,000 requests per minute. And we can see that we're in our error graphs, we're seeing certain spikes at certain times. Let's dive straight in to our profiling function. So we can see here CPU usage over time with our profiling graph. We can sort it by total CPU time. We can see that our runtime service here is running at 33 seconds. And with the zero self-time, we know this means that everything beneath that function is causing the issue, all those child resources. And looking at this instantly, I can see a lot of gRPC issues. I can see some syscall issues as well, some potential server issues potentially there as well. This is kind of telling me that we definitely have a gRPC issue, which could be third-party related. But we also have a high density of network-related functions. That's suggesting to me that we need to maybe potentially optimize network I/O or implementation. So, one key benefit of continuous profiling as well is drastically reducing that mean time to resolution. So without profiling, this type of investigation here would be potentially hours of guesswork. We can immediately see which functions are consuming the most CPU time, transforming the process from hours of investigation to potentially minutes. So beyond improving this performance, we can also see the amount of cores that are being used, CPU cores. We can see a minimum of 0.03 or a maximum of 0.12. So if we're provisioning instances with 4 or 8 cores for this type of thing, that would be significantly over-provisioned. So we can see here how this profiling also gives us an opportunity to optimize and reduce resource sizes and decrease instance count and potentially lower our cloud spending. Now, back to the issue at hand, I want to have a look at correlation. So I want to start using some of the other tools within Coralogix and see if we can identify any other performance bottlenecks. Let's go look at our service map. And we can see that our front end is making about 83% of the requests to our product catalog service. Now, if we right-click on this, we should be able to go in and view our traces. Yes. Excellent. So we're now sorting this by time. We can see which actual API endpoints are being called and the response time and any errors. So we can see several requests here to things like currency, product ID, giving us specific endpoints to go off and investigate further. So let's go in and see something for set currency, for example. So this is giving us even more insights. We can see a rich, detailed visualization of our services from the actual requests right through the whole application. So this unified approach, we're able to, we're not just looking at profile data in isolation, we're able to correlate potentially high CPU usage and GPRC handling with the specific endpoints and transactions shown in the service map and the transaction list. So we can develop a targeted optimization strategy that addresses the exact points of inefficiency. So continuous profiling is really transforming how teams can approach performance optimization by providing concise code-level visibility into production systems. It's really trying to bridge the gap between knowing when something is slow and understanding exactly why, the exact line of code is causing an issue.